Good afternoon. Welcome to Chemistry with Mr. Olson. Today we're going to do some mole-to-mole conversions. And first, we're going to review conversion factors in general. An example of a conversion factor would be, 1 meter equals 100 centimeters. So we could write 100 centimeters over 1 meter, and that's actually equal to 1. And the inverse is also equal to 1. 1 meter over 100 centimeters. It's just that the top and bottom of the fraction of the ratio are expressed in different units, but anything over itself equals 1. So this is a fancy way of writing 1. We can use this to convert between units using the given times conversion factor method. For example, if the Empire State Building is 38,100 centimeters high, how high is this in miles? Well, we can string together conversion factors. We can take our given number of centimeters, go out of centimeters into meters, so centimeters cancels, multiply by another conversion factor. 1,000 meters equals 1 kilometer. So meters divided by meters equals 1, it cancels, and kilometers over kilometers. Well, get out of kilometers into miles, and then we just multiply the numbers, and we get the number of miles. Rounding to the correct number of sig figs, that comes to 0.237 miles. And that is our answer. Given times conversion factor. We can also do the inverse. And we can convert from miles to centimeters, once again, by stringing conversion factors. But I want to get to mole-to-mole conversions. Here we have a balanced chemical equation. And since it's balanced, we know that for every one nitrogen molecule, N2, we use 3 hydrogen molecules, a 1-to-3 ratio. We're going to use 3 times as many H2s as N2. So we can write that information as a conversion factor. For every 1 mole of N2, we use 3 moles of H2, or vice versa. Let's do another example. Let's do it for the interesting one, H2 and NH3. For every 3 moles of H2, we produce 2 moles of NH3, and vice versa. Let's write that out. 3 moles of H2 correspond to 2 moles of NH3. And we can use that conversion factor, and of course the inverse also works. 2 moles of NH3 correspond to 3 moles of H2. There are our conversion factors. Now let's do a problem using these conversion factors. Let's see. If we use 6 moles of N2, how much ammonia will we produce? So our given is 6 moles of N2, and we multiply by a conversion factor. When we build a conversion factor, I like to start with what units are going to cancel. So we're going to want to get out of moles of N2, and it's asking how much ammonia. In other words, how many moles of NH3. Let's see, how many moles of N2 correspond to how many moles of NH3? We look at the balanced chemical equation. 1 mole of N2 corresponds to 2 moles of NH3. So 1 mole of N2 corresponds to 2 moles of NH3. Our units cancel, and we get an answer of 6 times 2, 12 moles of NH3. 12 moles of NH3. There we go. Box our answer. Beautiful. Let's do one more. If we use 6 moles of H2, how much NH3 will we produce? Okay, so given 6 moles of H2, we're getting out of moles of H2, and we're asked how much NH3. So we want moles of NH3, And now we need the numbers that make this a good conversion factor. How many moles of H2 correspond to how many moles of NH3? Well, we wrote our conversion factors right here from the balanced chemical equation. It's 3 moles of H2 correspond to 2 moles of NH3. That's this conversion factor right here that we wrote. So, moles of H2 cancel. We're left with moles of NH3, which is what we were asked. 6 times 2 is 12, divided by 3 is 4. We get 4 moles of NH3, and that's how we do mole conversions. We get the ratios out of the balanced chemical equation. Hope you've enjoyed this. Have a beautiful day.